do you feel comfortable with your working on broadcasts, broadcast domains, and collision domains? Do you feel comfortable with that now? Okay, very good. All right, let me test you a little bit. I see that your mute is on. Okay, that's no problem. You can just type your answers in. So here we have a network with 3 network devices and 6 PCs. If all of these devices, A, B, and C, if they are all hubs, how many collision domains do we have, and how many broadcast domains do we have? All hubs, yes. Actually, what we have is we have one big collision domain and one big broadcast domain, because hubs do not break anything up. Everything connected to a hub belongs to the same collision domain and broadcast domain. If you remember that switches break up collision domains. So whenever you have a switch, that is going to break up a collision domain. And if a switch has 4 connections to it, it has 4 collision domains. With respect to broadcast domains, only routers will break up a broadcast domain. So let's work on the another example here. Let's say that A and B are hubs and C is a switch. How many broadcast domains, or how many collision domains first, and then how many broadcast domains? Okay, you gave me 4 collision domains, which is correct. Okay, 4 collision domains. How many broadcast domains? And the question you've got to ask yourself is, are there any routers in this diagram? We said that A and B, no, there are no routers. Therefore, the broadcast domain will not be broken up. This is one big broadcast domain. Now let's say that A is a hub and B and C are switches. How many collision domains do I have? How many broadcast domains? A is a hub and B and C are switches. A is a hub and B and C are switches. So how many collision domains? And okay, Okay, you are correct about the broadcast. There's still only a single broadcast domain because there are no routers. However, every connection, okay, on a switch is a separate collision domain. However, when we are tied to a hub, every connection to a hub is a single collision domain. So if you count the PC connections, there are 6 of those. Okay, so we've got 1, 2, 3, 4, 5, 6. Those are 6 separate collision domains. Then up above, A, which is a hub, this makes one large collision domain. Okay, so altogether there are actually 7 collision domains. 7 collision domains. Okay, very good. Yes, exactly. 7 collision domains and 1 broadcast domain. Perfect. All right, now all the devices, A, B, and C, are switches. So how many collision, how many broadcast? A, B, and C are switches. One broadcast, correct. And you're saying 8 collision. Very good. Perfect. Perfect. Okay, good. Now, let's take it up a step. A is a router. B and C are switches. How many collision and how many broadcast? A is a router and B and C are switches. Perfect. Okay. Very good. So there are 2 broadcast domains because routers break up broadcast domains, and A is a router and it has 2 connections. Therefore, there are 2 broadcast domains. And there are, excuse me, there are 8 collision domains. So you count the 3 PCs over here plus the 3 PCs on the right, that gives you 6, plus 1 and 2 right here. So that gives us 8 collision domains. All right, I'm going to throw in a little curve here. I have A is a router, B is a switch, C is a hub. How many broadcast? How many collision? A is a router, correct. B is a switch, and C is a hub. Good. 2 broadcasts, correct. And 5 collision. Perfect. Okay, very good. So again, the answer for everybody else, if A is a router, B is a switch, and C is a hub, then we have 2 broadcast domains and we have 5 collision domains. Okay, gang? All right. Very good. So, I think you've got that locked down pretty well. Continuing to go through some of the early chapters, remember back in the midterm, we talked about the different. Let me get rid of some of this stuff. Let me show you something else. Let's see, where are we? We talked about the different types of PDUs. And if you recall, a PDU was a protocol data unit. So each layer has a different protocol data unit. In fact, I just want to take a real quick look here. No, that's not what I want. Okay. I'm looking for something here real quick. Hold on. Oh, here it is. This is what I want to show you. Okay, so you're familiar with the OSI model, okay, which has its 7 layers, and we talk about in the early chapters of the book. And here are some of the protocols that run in the different layers of the OSI model. Specifically, we're looking at some TCP protocols. And you'll see in the upper 3 layers, which generally get referred to as the application layer, we have things like DHCP, DNS, SMTP, HTTP, and HTTPS. Down in the transport layer, which is our 4th layer or middle layer, we've got both TCP and UDP. In the network layer, we have such things as IP, ICMP, ARP, RIP, and OSPF. And then finally, in the data link layer, we have protocols such as Ethernet or ATM. Now, if we take this one step further, these are some of the different PDUs that we have at the different layers. So at the transport layer, we've got segments and datagrams. At the network layer, we've got packets. At the data link layer, we have cells. And then finally, at the physical layer, the PDU is a simple bit. Now, generally, on the devices column, what we're showing here is the highest layer that a hub operates at is the physical layer. It doesn't go any higher than that. Switches, on the other hand, go one step further, one level further, and they communicate at both the physical layer as well as the data link layer, but not the network layer, unless you have what is referred to as a layer 3 switch. But for purposes of our class, all of our switches are layer 2 switches. The router, which exists in the 3rd layer, that's as high as it performs. It doesn't go any higher than the network layer. And then finally, we've got such things as a firewall. A firewall is kind of a router with additional sophistication for the purpose of protecting network traffic. And the firewall device operates at the transport layer. That's the highest layer it will operate at. Finally, devices such as PCs, servers, phones, laptops, tablets, all of these devices which are actually used by the end user, I typically refer to as hosts, and they operate at the upper three layers. They also operate at the physical, the data link, the network transport, but most of their work is done in the upper layers. All right, and again, these are the PDUs. So you should know what the PDUs are for each of these layers. Also, be familiar with what address type we use at each layer. So when it comes to transport, we use port numbers. When it comes to network, we use IP addresses. When it comes to the data link and frames, we use MAC addresses, and this is very important. So let's take a look at some of the different PDUs and some of the fields that are inside them. If you recall last time, I asked you to identify. Okay, can you hear me okay, Sharon? You're the only one out there. Okay, very good. So I asked you to identify the different PDUs. Let's take a look. So here are a couple of PDUs, and you'll notice that here what we have is, you'll notice that, ask yourself the question, what type of addresses are in these PDUs? And you'll notice that there's a source port number and a destination port number, and a source port number here and a destination port number here. So what type of PDU do you think these might be? What PDUs do you think these might be? And just so you have a chance, you've got your options are segments and datagrams, packets, frames, and bits. So what kind are these? Well, these happen to be segments and datagrams. Below here, we have a TCP segment, and we can tell that it's TCP because TCP is what we refer to as a reliable communication protocol, and it uses sequence numbers. That's how you can tell the difference between a datagram and a TCP segment, in that we have these sequence numbers in the TCP segment. Up here, because UDP, which also runs in the transport layer, is unreliable, okay, it's not as sophisticated as TCP, but that's by design. That's a good thing because it has a lower level, lower overhead. And so what we have up here is, this is a UDP datagram. A UDP datagram right there, okay? Notice it does not have the sequence numbers that we had in the TCP segment. All right. So let's see if I can find some of the others that I wanted to show you. This is an Ethernet frame, and the Ethernet frame is the PDU for the data link layer. Data link layer. Okay, an Ethernet frame. And then the last one that we have to find is, let's find an IP packet. And that's probably down here. Here it is, IP packet. So here we have the PDU for layer number 3. And the thing that keys you off that this is a IP packet is the source IP address and the destination IP address. You're not going to see that in any other PDU. So when you see source IP, destination IP, you're looking at an IP packet. Okay? Very good. Okay. So we're clear on that part, hopefully. And let me go back to Canvas. And let's just open up some of these other, I think we pretty much have gone through chapter 1. I just want to go through these early chapters quickly. So here this is. Okay, we talked about all of this. We talked about the layers. Make sure that you understand what connection-oriented and connectionless is, and that's part of chapter 1, as well as what is flow control. Flow control is used in with TCP segments, as well as the term windowing. Okay, so that's chapter 1. Chapter 2. Again, we talked about broadcast domains and collision domains. How a router breaks up broadcast domains. Do you know what the difference is between full duplex and half duplex? Okay, good. There is our Ethernet frame. Or no, this is not an Ethernet frame. This is simply a MAC address. So the MAC address is 48 bits altogether. Half of it is used primarily to identify the organization, such as Cisco. And the other half, the other 24 bits, are used to uniquely assign different ports. So again, here is an Ethernet frame. And you can tell because you've got the destination address and the source address, and it's only 6 bytes long. Okay. We talked about the different types of cables. I'm not going to go over that because most of you have that down and are in pretty good shape for that. Okay, so that's good. Let's go to chapter 3. We talked about the different layers already for TCP/IP and the difference between the DoD and TCP and the OSI models. That the OSI model was actually built off of the TCP model, which was built off the DoD model. know the different protocols that we have in here. And for stuff like FTP, you should know what ports FTP uses, or what ports TFTP or SNMP. Know the ports on these, as well as know what they're used for. So there is a TCP segment, okay? There's a UDP segment, and this is in Chapter 3. And there is an IP packet, okay? Again, the source IP address and the destination IP address, which will key you into that being an IP packet. Okay, you know what the different classes are. We've pretty much nailed that down. Okay, so Chapter 4 gets into fixed length subnet masks. So let's just do a quick example of that. Let me open up my all right. So I give you this address, 172.100.0. It is a /24. And we want to break it into create 7 fixed length subnets. Okay. So you're to take that address space, which is actually 172.16.100.1 through 254, and we're going to break this down into 7 fixed. Yes, we are going to have to borrow some bits. So how many bits are network bits, and how many bits in this address are host bits? How many bits in this address above are network bits, and how many bits are host bits? Remember, there are 32 bits all together. Okay, so there are 8 host bits, and therefore the remainder, 8 minus 32, is 24 network bits. So we need to borrow a couple of host bits. And yes, you are correct. We need to borrow 3 host bits, because we know that 2 raised to the 3rd is going to give us 8. And while we only need 7 networks, 7 subnets, 2 to the 2 is too few, because that only gives us 4. And 2 to the 3 gives us 8, which is 1 more than what we need, but that's fine. So if we look at this, if we look at these 3 bits, these 3 subnet bits, what we have is there are our 24 bits, okay, that we said we had initially up above here. And we're going to borrow 3 of the host bits. So I'm going to mark them as S. 1, 2, 3 host bits. And then the remainder, the remaining 5, 1, 2, 3, 4, 5, those are our host bits. So the question becomes, and you are correct, it's going to be a /27 ultimately, okay? So the next question we have to ask ourselves is look at the rightmost network bit, which would be this subnet bit right here. And we have to ask ourselves the question, what is the value of that subnet bit highlighted in blue? Correct. It is a block size. Our block size is going to be equal to 32. And once we identify the block size, then we start counting in multiples of 32. So 0, 32, 64, 96, 128, 160, 192, and that gives me my 7, and I'm just going to take it to 224, the next level up, okay? So those are our network IDs, correct? Do you agree? Yes, very good. So those are our network IDs. And again, I need 7 of them. So 0, well, let me put in the titles. We've got the first, then the last, then the broadcast, and so then we'll put in 0, 32, 64, 96, 128, 160, 192. We know that the first address is always one more than the network ID. So we got 1, 33, 65, 97, 129, 161, 193. Oh, and I forgot to write down here just 224, and that's not going to be, we're not going to use it, but again, it just helps. Now, let's do our broadcasts. So our broadcasts are always going to be one less than the next highest network ID. So here we have our broadcast address for the network ID 0. And if you look at the next network ID, which is 32, this broadcast is going to be 31. And then 63, 95, 127, 159, 191. And I wrote that 224 down here just to make this easier to figure out, which is going to be 223. Now, our last is always going to be, yes, I'll put in a CIDR column in just a moment. Thank you for reminding me. Okay, so our last is going to be one less than the broadcast. So 30. Broadcast is 63, so 62. Broadcast is 95, so 94. Broadcast is 127, so 126. Broadcast is 159, so 158. Broadcast is 191, so 190. And broadcast is 223, so 222. As a final check, remember that network IDs are always even, first addresses are always odd, last addresses are always even, and broadcasts are always odd, okay? And finally, let's put in CIDR, and CIDR is going to be, for all of these, a /27, because they're all fixed length, so they're all /27s, okay? Sharon, any questions? Very good. Thank you. Okay. So I don't think there's much need for us to go any further into fixed length. I think everybody's pretty much got that down. And now let's go in and let's talk about our variable length subnet masks. And let's see, I am going to open up another notepad here. Trying to get a hold of it. Here we go. So whenever you're doing VLSM, the first thing that you want to do is you want to ask the question, how many networks? Okay. And I'm going to simply tell you that there are going to be 5 networks in this problem. I may give you a diagram, but I'm just telling you here. Okay, that's the next question that we're going to ask, is how many hosts are in each network? So the first question is how many networks? Then you're correct. The second question is how many hosts for each network? And I'm going to say that there are going to be, for the first network, network A, there's going to be 2. And network B, there's going to be 2. And C is going to be 25. D is let's make it 59. And then finally, E is going to be 112. So once we identify how many hosts are in each network, we want to order them from largest to smallest. So okay. So what is our largest network here, Sharon? Okay, E. So E is going to be at 112. And what's next is D, and that's at 59. Then C is at 25. And then A is at 2. And B is at 2. So that's the number. That's the number of hosts. Then we've got, based on the number of hosts, what is the block size that I need for each number of hosts? So if you recall, your block sizes are 2, 4, 8, 16, 32, 64, and 128. So to fit the 112, what block size do I need? You are correct. I need a block size of 128. So for E, we have somebody join us. Okay. Heather, can you hear me? There we go. Did you just come in? No problem. No worries, okay? We've got a small little group. It's you and Sharon and I. Okay. So the block size that we need for here is 128. How about the block size for network D? How many do I need? Correct, 64. And the block size for C, 32. Okay, very good. And then 4 and 4, correct. Thank you, Sharon. Okay. Now, based on this, we need our network IDs. And we always start off with 0. And then we add the block size and the network ID to get us the next network ID. So in this case, 0 plus 128 gives us 128. And 128 plus 64 is going to give us what? How does 192 sound? Oh, not 102, 192. Okay. Then 192 plus 32 is going to give me 224. Then 224 plus 4 is going to give me 228. And just for kicks, I'm going to 228 plus 4 is going to give me 232. Okay? Any question on these, ladies? Okay, everybody's good. Very good. You guys are making it easy. Okay. And cider. Let's open this up a little bit. Okay. So, Heather, you want to give me my first IDs? So for network ID 0, what's my first host? 1, thank you. Then we go 129, 193, 225, 229, and we don't need to do that one. Now let's do the last, or the broadcast. So the broadcast is going to be 1 less than the next network ID. So the next network ID is 128. So we're going to do 127, 191, 223. Oop. There we go. Then 227. And then 231. And let's get our last before we do our citers. And so our last is going to be 1 less than the broadcast, 126, 190, 223, 227. No, I'm sorry. Sorry. 222. Okay, 227 and 230. All right, very good. Um, 236. Do you mean down here in this this row? Or 226? 226. Oh, yes. Thank you, Sharon. Okay. There we go. That better? Okay. Thank you. All right. So, Sharon, do you want to tell me what my CIDR should be? What's the CIDR for the first one? Okay. It's going to be a /25. Next is going to be you want to give that to me, Sharon? What's the next one going to be? /26. Then we're going to do a /27. And for the two networks that only have two hosts, we're going to do a /30. Okay. Okay, very good. Now, let's see what else we have. So any questions on the variable length subnet masks? Let me just fill this in case anybody's really paying attention. Order the networks, largest to smallest. Determine the block sizes. Okay. Determine the network IDs. Determine first host address. All right. So I think that's pretty much it for. I'm just going to take this and put it over here. Okay. All right. So we've got that. I'm just going to take this and slide this over here for the moment, out of our way. Take that, push that over here. And let's just go through and make sure that we're covering everything. So we did VLSM. We did not do summarization. Okay, and this is a typical classful network. Okay, that's fine. Anytime we're using VLSM, it's typically a classless network design. Okay, gang? There's VLSM. And he does it a slightly different way than I do it. If you prefer his method, that's fine. I'll figure that out on the test. But personally, I think you'll find mine to be much easier to deal with. Okay, so in summary, summarizing an address, here you've got 4 network IDs. The first is 10.0.0.0, The second is 10.1.0.0, then 10.2.0.0, and 10.255.0.0. These are all network IDs. However, one of the things that we can do is we can summarize all of this into a single network ID of 10.0.0.0. So we go from a /16 to a /8 to summarize all of these addresses. All right. Again, here's another summarization example. I think I did this one in class. We'll go over it again. If you look, they all start with 172.1. So we've got 172.1, 4.0, 5.0, 6.0, 7.0, and down below here we have 4.128. Okay, and that's because this network here and this network here is a /25 and a /25, which means that there are 25 bits into the subnet mask, and that is fine. But to summarize all of this, I've got 4, 5, 6, and 7. And if you look at these values in binary, okay. So if we look at the value 4 in binary using 8 bits, we've got 1, 2, 3, 4, 1, 1, 0, 0. That's 4. 5 is then 6, then 7, okay. So this value right here, this 4 or 5 or 6, if you look at these in binary, you see that they all share these 5 zeros and a 1. They all have, let me highlight this properly. They all share that. And what that value is right there is a 4. So to summarize this, okay, the address to summarize all of these addresses up above would be 172, 1.4.0 with a, we could use that as a let's see, 16, and then 16 and 6 is a 22, /22, okay? That would be how you would summarize all of these addresses for this route, okay? Yes, to answer your question, Sharon, yes. Summarization, you're going to see a lot more summarization in a VLSM environment, okay? But you can still see it with, fixed length, all right? Oh, I'm sorry. Oh, Steve, you're out there. Okay. I simply saw the S. Your messages come up in this lime green, and it's very difficult to see it at a distance. So I'm sitting back from my my desk. So Steve, yes, you are correct. We do see it more often in summarization with VLSM, but again, it is possible to see it with fixed length as well. Okay. All right, Sharon. Sorry about that. Okay. Questions? Are we good? Okay, so Steve, you'd like to try another one? Let's see what we've got. Let's see if I can come up with one on the fly. Oh, hold on, Steve. 1 second. 1 moment. No, that's not what I want. Okay. Let's see if he used a different one here. Okay, so let's see. I'm not finding any other examples here, Steve. I'll tell you what, I'll make one up for you. And I'll get that out to you. All right. So we'll just move on because I can't think of one off the top of my head, but I will put one together for you, Steve. All right, let's see here. Okay, yeah, that's all old stuff. All right. I think you all have the TCP/IP troubleshooting down. Let's take a look at our next chapter, and that would be chapter 6. Now, these are the new chapters after the midterm. Well, actually, we didn't do VLSM for the midterm. All right. So we're talking about the Cisco IOS, and quite frankly, we've been working with the Cisco IOS, which is the inter-network operating system for Cisco. And we've talked about the addresses. We've talked about the boot up process. You should read through this and make sure you've got this down. Okay, it's pretty straightforward. We also talked about how we could reset the configuration register. All right, so I will probably be asking some questions on that. Okay. Host names, banners, and so on. What do we got here? Yes, we use the configuration register for breaking into the router. And that I don't think I'm going to have you go through that process. I'm not going to ask you to break into a router. But I may ask you, what is the command to change the configuration register? Okay. You've been setting your password since day one for your console, your VTY, for your enable password, and your secret password. So I'm not going to get into that. We did not get into SSH. I did not talk about that, so I will not cover that in the test. Again, one of the commands that we can use to display the status of our interfaces, IP interface brief, and it shows you whether or not the interface is up or down, and whether or not it has an IP address assigned to it. You know how to bring up an interface, specifying int F00 with a no shut. Okay. So you've been through that many times. Again, just to remind you, the test is going to consist of 2 parts. First part will be a multiple choice, true and false. There may be like a kind of a fill in the blank, especially when we go to do a fixed length and variable length subnet masking. And then the second part of the exam will be a packet tracer part. You should give yourself at least an hour, and you are allowed to bring in your commands. Okay, you remember the command files? I strongly recommend that you have it on a USB so that you can copy and paste stuff rather than having to type everything in. It will help to reduce the amount of errors that you have, and it will also help to reduce you having to look things up in the book. Okay, so please do that. We have gone over numerous times how to configure the serial interface between 2 routers, so I'm not going to go through that again. About having the clock rate on the DCE side. Okay, so there's the DCE and the DTE, and we only do clock rates on the DCE side of the connection. The last lab that we went through, we talked about, copying our configuration files. Not only how to copy them, but how to back them up to a TFTP server. So I may be asking for some of that. So make sure that you review that in the last lab. I don't know what I did here. Okay, I'm not sure what happened there. Okay, so that takes care of Chapter 6. Let's take a look at Chapter 7. Again, Chapter 7 is very basic. A lot of what was in Chapter 7 we had been talking about since very early on in the course. I think with the exception of maybe CDP and so on. So let's go through this. Right, we did not talk about CDP until the second lab and so on. We did talk about DHCP and TFTP. Again, familiarize yourself with these components. These are in the first couple of pages of Chapter 7. Know what NVRAM is, non-volatile RAM. Okay, that's both in 6 and 7. How to copy stuff to your TFTP server. That was in lab number 8. how to restore your iOS by copying it from your TFTP, and you can see the command right here. Okay, copy TFTP, running config, or you can specify an operating system file. Erasing your config files, configuring DHCP. Okay, we did enough DHCP along with relays for DHCP. So you should have that pretty well in hand. Okay. Again, the IP helper address, which is used in a DHCP relay. And let me just look at this real quick. One of the things I want you to pay attention to is that this IP helper address command has been applied to interface F00 right here. This interface right here. And what it's doing, the 10.10.10.254, it's pointing to the server over here. Now, if your DHCP server is actually a router, then you have to point to an address on the router. Okay, we talked about syslog. That's pretty straightforward. Again, make sure that you've got these commands in your command file, and you can just copy this stuff, okay? Along with NTP, okay? CDP, we had that entire lab on CDP, and most of you did very well on that. And then how we document. I won't be asking you to do CDP. You should know what it is. You're more likely to see CDP in the true and false multiple choice section of the exam. I am not going to put it in the packet tracer. It takes too much time, and you know, you're going to be brain drained by the time we get to that. So I don't want to do that to you. Okay. All right, so that's 7. Next, we've got 8. Again, some more of the TFTP and so on. And we also went into password recovery here. The boot process, know what this is, okay? The configuration register, this is where we broke into that router, Steve. But again, we are not going to do this as part of the packet tracer. I may ask questions about configuring the configuration register, but I am not going to have you do it as part of the packet tracer portion. Okay, this is where we essentially are able to copy our iOS from the router to a TFTP server, okay, or copy it back, and we did that as part of Lab 8, or how to restore or upgrade our iOS. I'm not going to get into licensing. We did review it, but I'm just going to leave it out for right now. Okay. Nine had to do with looking at our routing. We talked about 3 different types of routes. We talked about a static route command. We talked about the dynamic routing, and we talked about default. Let's blow this up so you can see it a little better. All right, so there are our objectives, basic, routing, a destination address, network neighbor routes, possible routes to all networks, the best route to each remote network, and how to maintain and verify routing information. So here is a diagram. It consists of actually 4 networks. And you can see that there's one way out here. Now, you don't see any addresses for going out, but what you do see is a outbound port or an exiting port number. And this is what the routing table for that network would look like. And it's essentially saying that, it's variable subnetted. Okay, you can see that right there. And then you can see the different networks. And then there is one static address, and this is the default network. And that's why you see the S, okay, with the asterisk there, okay. Should probably walk through these, although we did that in, when we went over routing. Again, static, default, and dynamic. Dynamic is done using a routing protocol such as RIP, which is what we are using through the semester, as well as OSPF, which we'll be getting into once we come back into session on class 234. So dynamic routing is done with routing protocols. Static routing is set up by the administrator, and default routing specifies for any network where we don't know how to get to, this is going to be the default route out. Here is a static route command. Oh, sorry. I can't seem to highlight that. But again, it's IP route, then the destination network ID, a network ID, subnet mask for that network, and then you have to specify either the next hop address or its exit interface. Okay, know what the difference between those two. And then finally, what is the administrative distance? Okay. And specify whether or not it's permanent or not. Okay. So here's an example of a static route command, IP route 172.16.3.0, which is our network ID, followed by the subnet mask for that network ID. And then this is the exit or the next hop IP address. Okay, so that's the address of the next router over. Here, we specify almost the same thing, okay, as above, only we add an administrative distance of 150. Then finally, down below here, I have an IP route, again, 172.16.3.0 with a 255.255.255.0, and then we specify the exiting interface, which in this case is S000. Default routing. What the default route says is that if the router doesn't know the network that you are looking for, then by default, it will send it out based on this address, based on this command. So IP route, you specify 00000000, which means essentially all networks, and send it to the next hop address of 172.16.10.0. Are you guys able to see me okay? Are you able to hear me? Okay. I just got a message up on my screen that had me a little concerned. Okay. Everybody doing all right out there? Okay. Very good. Okay, let's see. Dynamic routing, again, is part of the routing protocols, and different routing protocols have different administrative distances. All right. You should know the administrative distance for a connected interface, for a static route, for EIGRP, OSPF, and RIP. Don't worry about external EIGRP or unknown. I won't be asking you that. Okay? Know the difference between the different types of routing protocols, the distance vector, the link state, and the hybrid. Just read through this page and you'll be fine. Okay. Last chapter, chapter 10. Okay. Chapter 10. Here it is. So layer 2 switching. We talked about the broadcasting, the forwarding, the flooding. You should know what that is and how that works. If you are having problems, go back and review the video that we put together. Okay. Know your port security commands. Okay. He does a pretty good job of going through that in the book about how to restrict ports. So read through those couple of pages, make sure that you understand that. We will not be talking about STP. I know I talked about it in class, but I'm not going to test you on it. Nothing on STP, gang. Okay. All right. You should know these commands: show MAC address table, show interface VLAN 1, as well as show IP interface brief. All right. And that's pretty much it. Questions? Okay, what's this? Steve, for Tuesday night, that's server class. That's not this class, right? Okay, I'm confused. You're not talking about Tuesday night, correct, Steve? We're talking Thursday night here in this review. And yes, there will be a packet tracer in the Thursday night class. Okay. Okay, very good. No questions at this time? Okay, okay. Sharon, are you okay? All right, very good. Very good. Steve, I I don't understand. What is scheduled for Monday night? We already did our review for 244. Remember, that's where we went through all the questions? Right. I don't know if you missed the message, but I was double booked. I had a client meeting Monday night. So the second session for 235 will be Tuesday night. Okay? Tuesday night. Okay, yes. Tuesday night will be the second session for 235. I have recorded this session and I will be posting it. It takes a little while to get it processed, so you should see it by tomorrow morning. Okay? All right. Well, I'll be recording it and you can watch it when you have time. No, it's not going to be packet tracer related. Okay? I'm basically going to do exactly the same thing that I did tonight. Okay? All right, gang. Thank you so much for spending time with me tonight. And you're more than free to join us Tuesday night. Otherwise, I will see you all on Thursday. Okay? And again, if you've got a question, please don't hesitate to ask. The best way and the fastest way to get my attention is to simply send me a text message. Okay? Remember to put your name on it so I know who it's coming from. All right, gang? Thank you again. I hope everyone had a nice Thanksgiving. I will talk to you all soon. Take care. Bye.